Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss vector and scalar potentials. Let's begin. Vector and scalar potentials. Basically, we have to discuss Maxwell's equations in terms of vector and scalar potentials. First we write Maxwell equations. 4 Maxwell equations are written here. From that of equation number 2, first we define what is vector potential and scalar potential. From equation number 2, that is grad dot B is equal to 0, means divergence of a vector is equal to 0. What it indicates? It indicates that B vector is solenoidal. When the divergence of a vector field is 0, then that vector is called solenoidal. Again, we know from the property of vector identity, we know that divergence of curl of a vector is also 0. That is divergence grad dot curl of a vector grad cross A is equal to 0. Let that one as equation number I, this one as equation number I. Comparing equation number I and I, comparing equation I and I, we get that B vector is equal to grad cross A vector, and here that quantity A vector is known as electromagnetic vector potential. Here the quantity A vector is known as electromagnetic vector potential. Okay. Next, from equation number 3, from equation number 3, that is grad cross E is equal to minus del B by del T. In place of B we can write that is grad cross A, grad cross E is equal to minus del by del T grad cross A, or grad cross E is equal to minus grad cross del A by del T, that term to this side is equal to grad cross E plus grad cross del A by del T is equal to 0. Common term grad cross E plus del A by del T is equal to 0. Call of something is equal to 0, then that term is also called irrotational. It indicates that term E vector plus del A by del T is irrotational. As its call is 0. Again the property, as you know, again we know that the curl of gradient of a function gradient of a scalar function is 0, that is grad cross grad phi, grad cross grad phi, that is gradient of a scalar function is equal to 0. Therefore, now the equation can be written as grad cross E plus del A by del T plus a term grad cross grad phi, as is result is equal to 0. If we add that quantity to that term, there will be no such change. Therefore, grad cross E plus del A by del T is equal to minus grad cross grad phi. On both sides we obtain E plus del A by del T is equal to minus grad phi. Curl of both sides cancelled. Therefore, E is equal to minus del A by del T minus grad phi. So, E in terms of a scalar function, whereas phi where phi is known as electromagnetic scalar potential. Electromagnetic scalar potential. From equation number 2, we show what is electromagnetic vector potential and that B vector in terms of electromagnetic vector potential. From equation number 3, we show what is electromagnetic scalar potential and E vector in terms of that electromagnetic scalar as well as vector potential. Again, from equation number 1 and equation number 4, we can show in terms of vector and scalar potentials. Next, from equation number 1, grad dot d is equal to rho. As we know, d is equal to epsilon into E. So, grad dot in place of d epsilon into E equal to rho, or grad dot E is equal to rho divided by epsilon. Previously we derive E, the value of E is put at grad dot del A by del T plus grad phi is equal to these are the minus terms, minus del A minus grad phi, rho by epsilon minus as common multiplied to that side grad dot del A by del T plus grad phi is equal to minus rho by epsilon. Or that one is del by del T of grad dot A plus grad dot grad phi, grad square phi is equal to minus rho by epsilon. Now, we add and subtracting a term on both sides, in the left hand side of that of equation, here adding and subtracting mu epsilon del square phi del square T in that equation. There will be no such change. Now we add and subtract. We write it as grad square phi minus mu epsilon del square phi del T square plus del by del T grad dot A, then subtracting, here subtracted, then adding, add mu epsilon del square phi del T square is equal to minus rho by epsilon. Grad square phi minus mu epsilon del square phi del t square plus in these two terms if we taking del by del t, then inside that of bracket grad dot a plus mu epsilon del phi by del t is equal to minus rho by epsilon. From equation number 1, we show that Maxwell's equation in terms of phi, that is the scalar potential. Next, from equation number 4, also from equation number 4, grad cross h is equal to j plus del d by del t. Here we can use in place of d epsilon e and in place of b mu into h. So that equation can be changed as grad cross in place of h b by mu is equal to j plus del by del t in place of d epsilon into e, or grad cross b, that mu is multiplied, so mu j plus mu epsilon to that of outside del e by del t. Now b in terms of vector potential, it is grad cross a is equal to mu j plus mu epsilon del e by del t. Using the property of vector identity, it is grad dot a minus grad square a is equal to mu j plus mu epsilon in place of e, that is del by del t in place of e minus del a by del t minus grad phi. Now simplifying it, grad dot a minus grad square a is equal to mu j plus mu epsilon that is minus mu epsilon del square a del t square minus mu epsilon del by del t of grad phi is equal to mu j minus mu epsilon del square a by del t square minus mu epsilon grad of del phi by del t. That is the term grad dot A minus grad square A. Now multiplying negative sign on both sides, that is grad square A minus grad dot A is equal to minus mu J plus mu epsilon del square A by del T square plus mu epsilon grad of del phi by del T is equal to, only that term we have to take in this side and all the terms to that left hand side. We have grad square A minus mu epsilon del square A by del T square minus grad dot A minus mu epsilon grad of del phi by del T is equal to mu J. Only that term in that of right hand side, all the terms to that of left hand side. Now rearranging the terms, grad square A minus mu epsilon del square A del T square minus grad as common, in that of bracket we have grad dot A plus mu epsilon del phi by del T minus mu J. Maxwell's equation in terms of vector potential A vector. Let I take in that equation number, it as equation number 5th, this one as equation number 6th, equation number 7 and equation number 8. These are the equations of Maxwell's equations in terms of scalar and vector potential. So here with the help of this video lecture we understand the idea of vector and scalar potentials and Maxwell's equations in terms of vector and scalar potentials. And the four Maxwell's equations, from Maxwell's equation number 2 we show that B vector is equal to grad cross A, whereas A is electromagnetic vector potential. Next, from equation number 3 we show that E vector is equal to that one, and here phi is the electromagnetic scalar potential. Now from equation number 1, that is the Maxwell's equation in terms of scalar potential phi, that bracket term is same in equation number 7 and equation number 8. Here equation number 8, Maxwell's equation in terms of vector potentials, that bracket terms are same. These are the equations as we derived are the Maxwell's equations in terms of scalar as well as vector potentials. So with this useful and informative notes, let me wind up the session. Thank you.